All right, electricity class. This is Mr. Voigt. We are going to go over simple series circuit value or characteristic calculations. So what we have here is a simple series circuit. As you can see, there is one path for electricity to flow, and it doesn't matter which way it flows. So there's one path here, this way or the other way, and it goes through all three of these resistors. Okay, so we have a 9 volt, so this is our total over here. We have 9 volts total, 9 volts total. At resistor 1 we have 100 ohms, at resistor 2 we have 300 ohms, at resistor 3 we have 50 ohms. And so you can list these things up here, like I could go volts, they're V, A, R, W under each one of these. Or lots of times over here, you can make a chart, and this is where we're going to do it most of the time, and it's something like this. So volts, amps, resistance, and watts. V or E, A or I, R or ohms, the omega symbol, and W or P for power. And then over here, we go T for total, R1, R2, and R3. Now, lots of times I'll have these things filled in for you. You know, the top and the bottom, and you just got to fill in these. And then we go and we fill in what we know. We know we have 9 volts total. And we know we have 100 ohms at resistor 1, 300 ohms at resistor 2, and 50 ohms at resistor 3. All right. So now, remember, we're looking for 4 variables. We need any 2 variables at each one of these resistant points, the total, 1, 2, and 3, in order to figure out the other 2 values. But you have to use your logic rules for a series circuit, because this is a series circuit, in order to figure it out. So here are our logic rules. Current is the same. Current is amperage. So the amperage is the same at any point in the circuit. What that means is if we know the amps, oh gosh darn it, I wrote these wrong, so I'm just going to reverse these. I apologize. Usually to go VAR W, but since I wrote my ohms here by accident, I'm just going to change it over here. Anyway, if I find my amps here, that means I know amps in all those in a series circuit. If I find my amps there, I know all the other ones in a series circuit. It is not the same in a parallel circuit. It says the total resistance is the sum of the individual resistors. So I know to get this, I just have to add these up, right? And then the final rule is the applied voltage. That would mean our total voltage, the voltage applied to the circuit. And in this case, that's our total. So the applied voltage is equal to the sum of the voltage drops across the resistors. So anytime the voltage at this resistor is my voltage drop. Okay, so the theory behind that is I have 9 volts here. This resistor is going to use some of those 9 volts. This resistor is going to use some of those 9 volts. This resistor is going to use some of those 9 volts. Together, they use all 9 volts. You have 0 volts on the coming back on the other side. Okay? All right. So, those 3 rules, and I'll come back, I'll throw this back up there in a minute. But we know we need any 2 of these at any given point to find the third. So since we know that total resistance is the sum of the resistors, that one's pretty easy, right? We can find this one, 100 plus 300 plus 50. So you add those together, you get 450 ohms total. Now we know 2 variables here, so we can figure out both of these other ones, right? Using our formula wheel. So if I bring this back up and now I'm going to look at my formula wheel, I'm going to just go ahead and do amps, which is represented here as I. I know my resistance and I know my volts. So volts divided by resistance gives us our amps. So I'm going to take out my trusty calculator, turn it on, clear it. Volts. I have 9 volts divided by 450 amps. And I get 0.02, I'm sorry, 9 volts divided by 450 ohms gets me 0.02 amps. And always label these. Always put your symbols on them. And if I come back, it says if I know the current is the same at any point in the circuit. So if I know my current at any one of these points, I know my current at all of these points. So now, since I know my current here, I can go like this. So now I have 3 variables here and 2 at all these other points, which means I don't have to use my logic rules anymore. I've used 2 of these logic rules, right? I used this first one in order to add up my ohms and get my total. I use my second one to figure out my amps and then distribute them back over because they are the same everywhere. Now I don't need any of these anymore. I didn't have to use my third one. I come down here and I just use my formulas to finish this out. So let's go ahead and see what we got here. We got wattage over here. Well, if we go to wattage, that's P. I would just come over, since I have all 3 variables, I could use any one of these 3 and I should come up with the same answer. I'm going to use the simplest one, volts times amps, or V times I. So volts times amps, so 9 times 0.02. So I take I'm going to clear it, 9 times 0.02, and I get 0.18 watts. Now, just so you know, watts has the same in both a parallel and series circuit. All the watts at my resistors, the work done at my resistors will all add up to my total. So it's the same in either type of circuit. So now I want to decide on these other ones. Do I want to find volts or do I want to find watts? And what I do, so I know I have R and I know I have V. If I want to find volts or watts, I'm sorry, I know I have A or I and I know I have R. These are the 2 I have. So if I want to find volts, I and R, I just multiply them to get volts. That seems like it's pretty easy. So I'm just going to multiply these and get my volts each time. Okay, so I'm going to go ahead and do this. 100 times 0.02, it's going to be 2, right? So I can do this all the way across. If this is 2, 300 times that's 3 times as much. It's going to be 6. And if you need me to do it on the calculator, I will. 300 times 0.02, 6. And this is half of it. So 50 times 0.02 is going to be 1 if 100 is 2. And again, if you need me to do it on the calculator, 50 times 0.02, 1. Okay, so 1 plus 6 plus 2 equals 9. That is my rule number 3. So I came back and checked everything out by using my third rule. So I now have used all 3 of these rules, and they all work. So then down here, all I'm going to do is use that same formula I used here. I took volts times amps to get my power. 2 times 0.02. 2 times 0.02, and I get 0.04. And 1 times 0.02 is going to be 0.02. And by the way, I should put my watts on those. And 6 is going to be 3 times as much, right? So 0.12. But if you need me to do it on the calculator, 6 times 0.02, 0.12. So I got 0.02 plus 0.12 plus 0.04 is 0.18. It all checks out. So that is how you do a series circuit. I'm going to give you, there's another series circuit. So this is practice. This is just for you to watch me do. There's another series circuit that I have posted. I'm going to post another video that will give you the answers to that circuit that I want you to do for practice. Okay, so do the one I posted for practice. This one was just to listen to, and then I will have the answer. And eventually you're going to have to be able to do this without my help. Okay, guys, thanks.